Sorry about that. I'm sorry I'm a little late. I know I normally stream at 1. I had to do something very important. I had to eat some goldfish. I didn't finish eating goldfish. I have them right here. I like goldfish. They're good. They're good. Not sponsored by goldfish. Big Goldfish sponsored me, actually. They love me so much. The official snack of, it's not. It's not. Not, I swear. What were we doing? Oh yeah. Oh yeah. We were, I could do this actually a different way. I think I might do this problem a different way. So we had this plane. I'm gonna get rid of that. I remember how I did this. Oh, it's taking a long time to save. I like that. So we were doing... Walk away from my mic into the wall real quick. We were doing... sort of... some linear algebra stuff. But, thematically, we were using it for least squares projection. Is sort of where we were headed with that. So that's the kind of stuff we'll be doing today. So this plane point stuff. The problem here is we've got a plane made of 3 points. Find the point in the plane that is closest to the point 1, 2, 3. So 1, 2, 3 is not in the plane, but we can find an approximation by projecting onto the plane. And that the vector that's going to be the distance of the vector. So we're trying to find the point in the plane. So we actually want, if this is our little picture, we've got some plane, we've got some rogue vector, or this is our plane made by, you know, these 2 vectors, which we'll construct. We're trying to find, I mean, really, let's say this is the rogue vector. It makes a little bit more sense. That point that we're trying to find is going to be right here, perpendicular. So we want this vector. Most of the time, or some of the time, we'll be looking for this distance, and then we'll need to find. So it'll be this vector minus this vector, this one right here. That'll give us this vector, and then we can find its magnitude. But it's a little easier. We're just trying to find that projection. We're not trying to subtract the projection. So we need our 2 vectors. Okay, well, it's really easy. 0. Some nice mic demon right off the bat. Damie, no. Yeah. Oh, I had you muted? Oh, good. There was Mike. There was Mike's demon. Alright, what was I saying? Okay, Mike demon. Sorry, I'm eating goldfish. We're trying to find, if we have a plane that's created by these 3 points, so like here, 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 or something, we have another point that's like all the way out here, and we're trying to find the point that's closest to it in the plane. So we have to project this vector onto the plane to be able to find that. So we're going to take our 2 vectors, and trying to decipher numerous puzzles, and I'm stuck, so I guess I'll watch you. But puzzles? Wait, you can't just come in here and be like, I'm trying to get puzzles. I love puzzles. I'm like the puzzler. The grinning puzzler. The grinning smiler. That's me. You? I'm the puzzle? I mean, Yeah. Oh, I have no clue how big this is? Ooh. Well, now I'm intrigued. Now you gotta tell me. I don't remember what my A is. I think my AV is column space for A, so I think we can just go for this. Yeah. Took 3 weeks to get to the point where I am. Well, at least tell me what the puzzle's about. How about that? Start there. Is it a puzzle that's been solved? So we need A transpose times A. God, this matrix trick is so sexy. If you put the transpose like this, you can foil it. Oh, oh, so beautiful. I don't think anyone has seen every terminal page. Oh, is it like something that somebody kind of made up, or? Oh, okay, that's a funny way of saying that. But you know what I mean. Okay, so 0 times 0, plus 1, plus 1, 2. 0, 0, 4. 1, 0, 4. 1, 0, nope, not 4. 16 plus 1, 17. The website with over 1,000 pages, but some of you require puzzles to get to them. Ooh, that sounds so cool. I have to do this inverse? Oh god. Wait, no I don't. Ugh. Okay, I do. I lied. A transpose times Y. Okay, that's gonna be... times... transpose times... The atmosphere is kind of strange. I'm not... I don't hate strange atmosphere. Let's see, this is a 2x3 by a 1x3. No. Is it rows then columns? It is, right? So 3x2, 1x3. Wait, isn't that like... No. 3 by 2, and then 3 by 1. Wait, that's wrong as well, though. What the heck? Oh, well, oh yeah, it's okay, because this is going to be a 1 by 3. So it's going to be a 1 by 1? What? Hope you don't have epilepsy? No, I don't have epilepsy. Why am I, like, blorping out on this? I think... Okay, it's a 2 by 1. Okay, so we do the first one, so it'll be 0, 2, 5, 1, 0, 12, 13. And then we have to flip these, so 17, -4, -4, 2, times 5, 13. Now we're trying to find the point, so we're gonna have to change bases. My worst nemesis. Algebra. 33. And then -20 plus 26. 6. This is a 2 by 2 by a 2 by 1, so it should be... Should be a... Oh, a demon? Actually? Wait, did the demon stop on its own? Wait, maybe the demon stops on its own. I don't know if I've ever let it run enough. Because it stopped and I didn't do anything. Whoa, wait, how long was it? So the thing is, like, I don't have anything electric on my desk. I'm trying to figure out what the demon is, you know? I wonder if it's something in my OBS. It could be. Maybe it's something you guys do. Maybe you somehow get the demon out. I'm gonna just do matrix multiplication calculator real quick so I can make sure I'm doing this right, because it's been about a year since I've done it. 5 seconds. Okay, how loud was it? Was it like really bad? It was probably really bad. Oh god, are those given as columns or rows? 1, 2, 3, 3. Okay, they're given as columns. Or sorry, rows. Normal demonage. Well, I don't actually know how bad it used to be really bad, but I feel like I turned it down somehow. Maybe I didn't though. I don't know. You'll have to excuse my demonage. I'm sorry. Literally just demoning it up over here. 2, nope, 5, 13. Let's see. 33.6. Let's go, baby. I can add 3 numbers together. Not even 3 numbers, 2 numbers together. Okay, so we did that. Now this is the linear combination. So this is in our basis of A. Basis A. We have 33 of the first one. Of 0, 1, 1. Plus 6 of 1, 0, 4. So in standard basis, that's going to be, let's see. So 6, 33, and then 33 plus 24 bases. Yeah, so generally when we write vectors, like when you write a vector and you don't put any subscript on it, and you say maybe it's like 1, 2, 3, right? What you're saying is this is 1 in the I hat direction, which is actually a vector in and of itself, right? That's like you're saying we have 1 step in one direction, and there's 2 in the j hat direction, which is 1 in the y direction, and then there's k hat, which is 1 in the last direction or z direction. And this is called a standard basis because it's the easiest way to represent stuff, right? If you want to make 1, 2, 3, you say, okay, I have 1 times my first vector plus 2 times my second vector plus 3 times my third vector. Because they're just ones, right? But you can also say that these vectors are different things. You don't necessarily have to have these 3 vectors here. And so in our case, we're in the basis of A, because our A is these 2 vectors. So that means that when we write the vector, if we were to write the vector 1, 2, 3, or in our case 1, 2, we wouldn't be saying, okay, it's 1 times 1, 0, 2 plus 2 times 0, 2. We would be saying it's 1 times 1, 0, 1, 1 plus 2 times 104. So that's the change of basis thing. And then you can also make a matrix to like change a vector's basis into a different set of vectors. It's just a computation thing. This one is a little nasty because it's 33 plus 24, which I don't know what that is off the top of my head, like 60, 50, 57. So that's what our vector is in the standard basis, saying like, okay, we're going 6 in this direction, and then 33 in this direction, and then 54 in this direction. I love decoding a clue just for it to be something I figured out from context. That's like, I don't know, I'm so used to just doing stuff like that because engineering is all like, oh my god, I just did so much extra work and I didn't need to do any of that because I just made an assumption that simplified the entire thing. Like we were solving, oh my god, it was actually a pretty cool class. We were solving this problem where we had like a blender, and my professor actually brought in a blender. And the thing was, okay, there's like an amount of water in this blender, and you want to model like when you turn the blender on, how does the temperature of the water change? Because we were doing like work energy Reynolds transport. And there's this, the way you write it is like, okay, you have like some heat coming in or out, and you have, you know, some work going in or out. In our case, it was in. And then you have, you know, this term that's describing the energy leaving the system or going into the system, the rate of change of it. And then you have all these little energies crossing boundaries and stuff. And basically, we were just like, well, this is basically nothing. This is basically nothing if you think about it. So it's basically just this, and then it boiled down to like being a line. And I was like, oh my gosh. It's really cool. And we actually did it. It was really fun. He like turned on the blender, and we like saw the temperature of the water actually go up like linearly for the like 2 minutes that we did the experiment. And everybody's like, whoa. Or I was like, whoa, that's so cool. I don't know. Experiment there. I was trying to experiment to see what I could do. Sorry for demoning you for slightly longer. My bad. Okay. System of equations. Oh wait, let me look at the thing because we finished. 10 seconds. I know. I cut it out that time myself. That was not a. I was waiting to see if it would go, and it didn't go, and then I was like, it's getting too long. My poor viewers' ears. Okay, let me check out this ARG. I do like ARGs, I will say. Let's see. Okay. Is it gonna be really loud? Oh, it doesn't matter. It maybe matters, actually. You guys are, like, here. The creator banned me from their Discord. Why did they do that? Rude. Okay. Something has obfuscated their voices once more. No matter, I shall make you listen. Oh wait, this is the one you showed before. Okay, I'm going to mute it. Just in case, sorry. Also, epilepsy warning. Because I deleted a message. That's so weird. Turn back now while you still have time. This is a dead end. Maybe what if I keep... Okay. Okay. The first Archant. Dreams have led me to this place, dear traveler. What of you? Having crossed the boundary, I can only assume that you are driven by a hunger similar to this construct. Yet be aware, in riding this eternal shadow soul, I have resurrected something of malevolence in turn. Will you possess a mere hunger, a worthless want? The construct is more than capable of consuming what it is needed to satiate itself. Look on, dare you see the truth. I feel like it's gonna just show me a big, like, a big picture of, like, a scary eyeball. Or something, you know? Look on, look on. They could have just made this like a video game. I wonder why they made it a website. Whenever I see sites like this, I'm like, wow. Oh god, my mouse just died. Observers like a video game? I forgot I can't interact with that. Anything interesting here? Oh, there's an autoplay. There's an ordered list. Oh. Why are there so many things in the... Oh, there's just a bunch of breaks in the ordered list? That's a funny way of coding that. Oh. You want me to skip you forward to... No, that's okay. This is cool, though. I like the fractals. Oh, I see. This is a very large image someone has decided to make. Wait, why can't I scroll down? There we go. Do I just have to scroll around this page until I find the thing? I don't know, I like this kind of stuff. I think it's funny. Oh, yeah, there it is. Place is mainly the same, is it? You know, well, this is the lore. This is the lore, you know? This is not math. I hope nobody comes in expecting me to do math right now. This is not math. It's okay. This is linear algebra. This is what happens when you project onto the fourth dimension. Don't worry about it. This isn't the lore? Well, this is like the intro, you know? Look, it's telling me, this terminal has begun to cease. I don't know what that is. The terminals take what the terminals will. Our desire to open the gate has led to this point. Our hunger is insatiable, unending. Eventually, the systems would break. I could not mitigate all the errors, all damages. The terminal has been annihilated time and time again in a fight against the costs. The chicken on screen? The chicken on screen? What? Oh no, why are they fighting against the chickens? Well, do not. We were given a will beyond comprehension, a will unbound, and my volition will not be dampened so easily. And so I shall test their resolve in turn, ceaselessly. I'm required to destroy every last terminal to ensure the opening of the gate, then so be it. In my death, there is no defeat. Oh. Well... what's this? Alter, terminal, connect, sacrifice. He's hearing this song. Die. Oh, corruption of space. Please. Eyes. Oh no, it's a big scary eyeball. Oh no, oh no. Oh, it's an image that doesn't load. Oh no. I do like the visuals, they're cool. Wow, it's just like Homestuck Moon. Sometimes images are links, yeah. Well, that's cool. That's pretty epic. Okay, check out this other awesome epic webpage. 57. Yeah. Yeah, I got 57. What about it? What about it? Wait, let's do this other one real quick, and then I'll take a look at it again. Okay, so I'm just gonna write this matrix real quick. So there's I'm gonna augment it. Sorry. I'm gonna augment it real quick. 1, -1, 1. 2, 1, 2. Times xy. Equals 1, 0, -1. Send a map, me and another making in the Discord so you can see the scale. Oh, that's cool. Wait, that's actually cool. I do like mapping web pages. Okay, so for context, this is a system of equations with no solution. Okay, so we know there's no solution. So we want to project, or close, we're trying to find the best fit approximation. So, best fit, project B onto A. This is our A, this is our V, this is our Y. So we can't get a solution, but we can get the closest solution that does exist. So the way we'll do that is by getting A transpose A. Literally just the same thing we did before. So, you know. How's everybody's day going? Hope it's going well. I'm having a good one. 1, 1, 1, 3. 2 minus 1, 1 plus 2, 3. And then 4 plus 1 plus 4, 9. It's symmetric. We'll do A transpose Y. Alright, so we're gonna get a 2 by 2? Question mark? No. Yeah. Yeah. And I eat 40 grapes live next to Mike. Why 40? That's my question. Why 40? So imagine I ate 40 grapes live. I can eat 1 goldfish live next to the mic. I don't know if that picked up. 40 is a reasonable amount of grapes. That's like an entire thing of grapes. An entire branch. Also, hi Corrupt, it's been a little bit. Hope you're doing well. 1 minus 1. 0. 2. Minus 2. 0. I feel like I'm doing something wrong. Doing something that involves dealing with finite differences in infinities? Ooh, I like that. Like countable infinity stuff? Oh, I need the int. It's just gonna be 0. Okay, I think I might have done something wrong. I don't need an orthogonal basis for this. I mean, I guess I could make it orthogonal. If I so chose. If I so choose. Unless I just did this matrix multiplication wrong, which, you know, is a very possible situation here. Maybe I'll actually write it out and we'll see if we get that. Columns into rows. Woo! It's been a while. It's been a while. No, yeah, we get that. Hey, Damie, wanted to stop in and say hi, but lurking because working. Oh yeah. I hope you have a good time at work. It was so cool. I like your stream a lot. I mean, I'll definitely try to catch more. I'll be able to catch more over the summer. I have a little bit of a wacky schedule for the rest of the quarter. Natural logs of 0 dividers needing to be considered. Ooh, how do you even do that? I considered them. I don't like considering them. I just stop. I'm like, yeah, I considered. Done. Goodbye. I really dislike that this is 0. This shouldn't be 0. That means that the 0 vector is our closest vector. And that's just not... I don't vibe with that. I guess we could try GSOP. Graham Schmidt. No harm in it. We'll see what we get, and then we'll see if we get 0 again. And if I get 0 again, then, well, I'll eat my foot. I don't know. Then I know it's 0, so. 2, 1, 2, minus a little bit of 2, 1, 2. Mostly 1, negative 1, 1. Me muttering to myself in my wizard cave. I wish I'd been able to catch your streams in grad school because I struggled with math. Aww. Yeah, math is hard. It's okay. I may have. I mean, I've only been streaming for a couple of years, so I may not have been around, or I may not have been doing this. What? Okay, maybe that's on my end. I did, that's new. I know I fixed it. I did switch the API. That's the part of my test screens project, investigating the 0 divisors in the test screens. I really, if you ever make a video on tesserines, I would love to watch that. I would love to watch that and understand it. That's very cool to me. Let's see. 2 minus 1 plus 2. 3. 3? Yeah. Quote unquote fixed? Okay, here's the thing. Okay, here's what I'll do. I'll do it right now, okay? I'll prove. We're going to Nightbot. I have to log in. Thanks, Nightbot. No, it's here. Okay, we're chilling. Commands. Custom. Follow time. I don't know what the token is, apparently. Let's see. Documentation. Wait, it's okay. Follow age. About 3,000 lines of code on it if you want to read it. Ooh, I might, but see, I might not be able to understand that. Okay. A token. Oh. Oh, I just have to authorize it. Wait a second. Can I get it? Oh. Oh. Okay, I just thought it was my username. Okay, try that. I don't know if that works. Because when I tested it, it said I can't follow myself, and then I was like, oh, I see. Whoa, also that map is really cool. I just looked at it. It works? There you go. C++, C#. Oh, but is it on... I feel like I wouldn't be able to... I mean, I know how to read code, but I don't know if I would be able to, like, understand, like, what's going on. You know what I mean? Nearly 2 years. I know, that's crazy. I feel old. Don't... Wait, 3/3. Okay. Hey, I don't mind that. I don't mind the 3/3. So then 2 minus 1 is 1. 2. 1. And then we can project onto this. So, we just want the... we want the best fit approximation, so... That's too long. I swear I didn't follow that far back. I've been streaming for 3 years, so... I know, it's crazy. I'm old. I'm not old. I'm young. But... I need to do projection, B onto A. Onto, I guess, like, U. Like, S, U. Gotta go bath. Look at bath. What is it called? Set? Span. Jeez. Been a while. 1, -1, 1. I can write letters, numbers. 1, 2, 1. Okay, so the projection, or I guess just like best fit. I'll just call best. It's an unhinged thing. I'm gonna call it B sub 0, B sub F, B sub 0, B sub 1. I don't know. Right now my zero divisor's investigation involves limits to approach values and look at their natural log, what terms diverge, and in which directions. Okay. So are you taking the... so you have a limit and then you take the natural log of the whole limit? Or you take the limit of the natural log? Let me think if I understand which one would be worse. I guess each would give you different information, kind of. I mean, the natural log of the limit wouldn't make that much sense, would it? It'd probably be the limit of the natural log. Okay, what is B? I already forgot. 1, 2, 3, 1, 0, -1. Just making up numbers. 1, -1, 1. All these are inner products, by the way. I mean, I could do them with vectors, but I just, you know. Just a little... feels cleaner to me. I get to see that it's actually the inner product, it's a generic thing, so I don't have to change my notation if we work with functions. Oh, that means add like an epsilon and see what it looks like. Oh, I see. Interesting. What IDE are you using? Just like Visual Studio? Or like more mathy stuff? Is it 1 minus 1? 0. Well, I might need to do something else to get a solution to this. Plus 1 minus 1. Okay, yeah. Okay, there's something else I gotta do first. I don't know why that's so weird. I'm gonna just leave it then. We'll do something else. .NET Fiddle, because I'm working off of a school-issued Chromebook that's locked down to be used to use anything fancy. Oh wait, are you still like? I can't remember if you're in college or not. I feel like I remember. I want to say you're in college, but I think you're probably not. Which that's like so impressive. Okay, I can't do that one. Define the matrix A and write the vector Y. I don't know if I can do that one, unfortunately. High school, wow. Good job. Good for you. Very much slay. Actually don't know if I can do some of these. What day is it today? Wednesday? Yeah, I got 2 classes before. Let's see. It's funny because we did a very in-depth look at least squares regression and the residuals and all that stuff in my measurements class, but this is such a funnier way of doing it. I mean, it's not. It's the same stuff. It's just like it's a better way of doing it. Think yeah, I don't think I can do 4 either, because 4 is also residuals. This one we did. Schmidt for that. Oh, the one thing about this is I think these are orthogonal. I'm not actually sure. Because if you have P O of x, I just assumed P2 of x was x squared. And so then it would be an orthogonal basis, because it would be like 1, it'd be 1, 0, 0, 0, 1, 0, 0, 0, 1, where your basis vectors are 0, x, x squared, or like 1x, x squared. But I don't know. It looks like I did not finish doing this. What the heck was I doing here? Wait, is that it? That might be it, is the thing. Demon really likes coming out this stream. That's great. I love that. Being sarcastic. That was... wait. Oh, that was 7. Wait. Oh, I didn't do 6. Oh, wait, we can do 6. I can do 6. Linear combination, baby. 10 out of 10 would blast my ears again. I'm sorry. So, I feel like I've explained this a bajillion times. Essentially, I edited out of all my YouTube videos, so if you, like, don't mind being about 4 months behind in the Damie timeline, but you don't want the mic noise, I do edit it out. But, yeah, so there's a demon that lives in my mic. It does not happen on my PC. It only happens on my laptop. I've put on noise gates. It overrides the noise gates. I don't know how. I've tried everything, basically everything. I thought it was electrical interference. I thought it was like a grounding issue. I thought it was all these things. I don't know what it is. It's something. I should be able to figure it out. I'm an engineer. I don't know what it is though. I think it's a power draw thing if I had to be real, but I don't know. So we are stuck with the mic demon until I can exercise him, which is hopefully this summer. My goal is 2 things. Given a zero divisor, decompose it into the form z equals ab, where a squared equals a. the absolute value of a equals 0, and the absolute value of b doesn't equal 0. Wait, how does a squared equal a? And a absolute value of a equals 0? What? Unless I'm just I think I'm reading the notation wrong. That's insane. 1 p1 of x, x, and p2 of x equals 1/2. I'm gonna break this up. 3/2 x squared minus. Yes. Express the function f equals x squared minus x plus 2. So we just project onto this space. I guess what I can do is, so it's actually funny because when I first got to this class, I was like, oh, I can just turn these into like vectors and then just project onto them. And then I was like, wait, I can't do that. And now I'm coming back and I'm like, yeah, I could do that because I remember doing that. Okay, I plugged it in upside down. Don't know if that's gonna work. It shouldn't do anything. Okay, I think I can just turn these into functions. I don't think I have to, like, deal with anything other than that. Not exactly sure, though. Let's try. So this would be... Okay, so we are projecting onto 3. So it'll be 1, 0, 0, 0, 1, 0. Second one? No. And then -1. No, I don't want to write it like that. Yeah, I do want to write it like that. Change my mind. That's our A. And then I need A transpose A. Which, yay, yippee! I love multiplying 3x3 matrices. Don't want to write this out again, but I'm going to do it anyway. It's fine. Don't worry about it. I could probably pull a 1/2 out. Whatever. Alright. Okay, here we go. It's gonna be symmetric, so at least we got that. That's 1. 0. And then -1/2. And then we've got that one I did, this one, which is gonna be 0. Did I do that right? Wait. Maybe not. Let me think. No, it should be not the, it should be here, I think. It'll be this one times this one, which is 0. This one times this one, which is 1. Yeah? Yeah. And then this one times this one, which is 0, I think. Yeah. 0.5 squared plus 0.5 squared equals 0.5 plus 0.5. 0.5 plus 0.5 equals 0. Wait, what? 1 plus j equals 0. 1 plus j equals 0 equals 0.5 plus 0.5j times 2? I don't... Oh, it's so hard to understand that. This one, -1/2. This one, 0. This one, 1/4 plus 9/4, 10/4. J squared equals, okay. So it's like I. I think if you like made a video and explained it instead of like if I had to read it through Twitch chat, then I could probably understand a little bit better. But I think it's a little hard to parse. Let's see, that's just 2. And then this one is -1. And then this one is, let's see, -1, 0, 1/2. Eight-dimensional tessarine is a zero divisor. I actually don't even know what zero divisor is. Let me see. Element A that is both A left and A right, zero divisor. Okay, that's not useful. In abstract algebra, an element of ring L is called a left zero divisor if there exists a non-zero x in R, such that AX equals 0. Okay. Or equivalently, if the map from R to R that sends X to AX is not injective, well, that means nothing to me. But the first thing means something to me. So, like, it's like if you took the dot product is a left zero divisor. If the vectors are orthogonal. I think. We'll say that. Don't know if it's right, but we'll say it. Oh no, I have to do the inverse of a 3x3. Oh no. Okay, well, we're gonna make it 4. We're gonna pull out a 4, okay. Okay. Can I even do that? Wait a second. I don't think so, right? Oh, I don't want to do that right now. I'm not gonna do that right now. I lied. Sorry. Sorry about that. I'm not gonna do that right now. But then I would just have to multiply them together. Like, I mean, this is pretty simple. It's just linear algebra. But I mean, I guess if people didn't do linear very well. I might actually need to do... Where's the function of that? I might need to not do it like that, actually. Because he gives me the integral, so let me try doing it the other way. Need to be orthogonalized for us to do this other thing, so I'll orthogonalize them. 1 and x are fine. But... Okay, so 3/2 x squared minus 1/2 minus the inner product of p2x and 1 over the inner product of 1 times 1 plus p2x x the inner product of x. Yeah, I think this is how we're supposed to do this one. Although you probably could do it the other way. I feel like you could, is the thing. But like, I don't want to push my luck, you know what I mean? Okay, so the integral of... How to do this? So the integral from -1 to 1 of just x squared minus x plus 2 over... Gonna be x from -1 to 1. Basically, if 0 is a zero divisor, limit x goes to z of 1 over x diverges to infinity. Limit as x goes to z of 1 over x. So, but how can a zero, like a zero divisor is a thing? It's a thing. It says it's a ring. An element of ring R. It's called a left zero divisor if there exists a non-zero x in R. An element of a ring. So we have a ring R and there is a non... But it's an element is called a zero divisor. I'd have to take a proofs course or something to understand, I think. Because, I mean, the issue with, like, a lot of this stuff is... From... How to say this? Like, if you wanna do engineering stuff, and you only know Physics 1, you could listen to an engineering lecture, and you would, you know, stumble around a little bit, but, like, you probably know most of the terminology. But, like, math isn't really like that, which is, you know, I'm a little sad that I didn't get to study it. But I also, I don't know. I'm glad that I'm not just doing theoretical stuff, because I like to do, you know, I like to do problem solving. 1 over z and ln z is undefined. Also, there exists another zero divisor that multiplies z to get 0. Sure. I think it like it depends. Like, I don't even know what a ring is. You know what I mean? Like, I have to understand abstract algebra if I have to do it. And that's just one of those things where it's like, it's quite hard to figure that out if you're not in the know about some of the stuff. Okay, so let's see. 1, that's 2. I could just multiply everything by 2, I guess. No, I need to multiply everything by 3. I don't either. I don't think it's required to understand tesseract math. I guess it's more just like, if it isn't, then I would probably need a lot more background on actual tesserines then, because I don't know anything about them. And so, it's x squared. Because, I mean, I think you can learn a lot of things without knowing that stuff. But also, with math stuff, it is sort of like you have to, 2/3. Oh, no. Yeah, 2/3. You still have that context, you know? Oh, nice. It is 3. It's 3 over 2. I'm gonna just put 3 over 2. I can pull out a 1/2. Which is sick, because I don't need to worry about that 1/2 being in there. Alright, let's see. So... I had no background on tesseranes when I started and derived the exponential and natural logarithm. Well, more power to you then. I think for me, I have to, for math stuff, I've never done any proofs or anything. So and I never felt like I had access to things where I could mess around with proofs. So that is the one place where I'm very lacking in terms of my proof stuff. Let's see, minus, is that a minus? Oh, it'd be minus the whole thing though, so minus that plus this. Let's go away. Plus, no, minus 4. I think the other thing is, like, I like math. How do I put this? I like math. I think that pure math is very beautiful. I also don't particularly... I don't have a very strong interest in, like, doing the pure math. Like, there are some pure math things that, like, I do enjoy, but it's more like I enjoy like, I'm like a pure math tourist, I guess is the best way I can say it. Like, I like going there, and I like seeing the local sites, you know, and like meeting people and talking to them. But I wouldn't want to live there. And so, like, I like using the math to do stuff, and I like modeling things that exist in real life, you know, systems and all that stuff. But, and I like knowing how the math works, which is more than some engineers like. But I'm not super interested in like being the person who proves the things. Partially just because it's one of those things that it would take me a long time. I know just for me, it would take me a long time to be able to get to the point where I could have a lot of fun with it. That's just for me. It's not like it's impossible or anything, you know. Okay, let's see. Can I do this? Does this work out? This looks like it might not work out super nicely. Oh boy, okay. I also could have made an error somewhere. Okay, so we got negative 2/3. Okay, -4 plus 2. That's a -2. We've got 6/4. -2, -6, -8. I messed around a lot with complex numbers before I did tesserines, and that helped a lot. Yeah. I think... like, I was always very bad at number theory. The school that school I went to for like a lot of my life, I had some really great people there who were very interested in math, and I was like a year ahead in math, and you know, I ended up taking like a number theory course, like not like a really rigorous one, but you know, it was focused on that sort of stuff, and I never had the sense for that. And not that you need the sense for that, but I never had the sense, and I never had the drive for it, really. Because I like, you know, this stuff is not my favorite. This is just very rote. But I do like using the math and saying like, well, you know, I want to be able to model vibrations. I want to be able to model, you know, the turbulence of this stream. And that's very exciting to me. But yeah, pure math stuff is not really my thing as much. I think I would probably like look into it a little more once I'm out of school and I have a little bit more like brain space for learning things that I don't just have to like use. But yeah. I don't like it. I don't like it. I'm just gonna leave it. I'll leave it. Not make it any better? No, it didn't. That -3 doesn't really do anything, I don't think. It multiplies everything. Oh, wait. Oh yeah, no, I multiplied the -3. It feels bad, but I don't know. I mean, I could just bite the bullet and go for it. Let's see. It would be 8 times 12. Plus 3. Or sorry. Going to 12, so that'd be plus 6. Or at least I get to say that I'm doing something that sounds absolutely ridiculous. Yeah, no, that's fun too. Like I do really like that. You know, it's cool to be able to be like, I'm one of a very small amount of people who like knows this information and gets to do this thing. And that, you know, my life has led me here. Finite differences of infinities and natural logs of zero divisors is a crazy statement. Yeah. I think the crazier thing is that you're working in like a numerical system that's not, or not an even numerical system, that you're working in a system that is not like one that people normally use. I think to a lot of people, they'd be like, what do you even mean? I mean, like, for people who don't understand, like, complex numbers or that kind of stuff. What am I doing? 8. It's 8. I don't know why I'm out here. 6 times 3 is 18. Jeez. 122 over 12. That is divisible. That's what? 5, 11? 61? over 6. 61, not divisible by 3. No, I think that's about as far as we can get. This one word that describes all that. Autism. Yeah, special interests go crazy. I love having an interest in learning and being curious and wanting to know more about the natural world. I think that's the way that you get good. Whether it's because you're... Man, this just sucks looking at this. Anyway, whether if it's because you just are like motivated or whatever, or because you have a brain thing that is motivating you, I think either way, that's the only way you get really, really good at something. Yeah, when people ask me why I'm good at stuff, I like don't really... I can't really just say like, Oh my god, wait, I have to do all this out for that too? Okay, well, fine. Onto U. S, span U. Okay. Was it? I don't remember. Minus x plus 2. I just say autism. Well, it's not only that. Or that's, because I also, like... I also really care about, like, teaching. That's my other big thing. And... I'm just realizing... Never mind, don't worry about it. I don't know if I need to orthogonalize it. But yeah, my big thing is, like, you don't need to... You can be any person and do anything. You just have to want it, you know? I'm gonna just say U3. Yeah, this is definitely not correct either. Because he gave me the Wait, why did he give me that integral? That integral's not hard. Oh, well, maybe a little bit hard. I don't want to work with someone else who's like officially really good at math, and especially analysis, and work with them with tesserines. When you get into college, you'll probably be able to find people if you math major. But at 18, I don't have any of those contacts. It's hard to find, I mean, those people just in general, I'm gonna be real. As a person who's in college and excited about doing things, it's... People want to do their own stuff, people want to get work stuff done, so... You know. I would say... You can always email people who write papers. I see. You're going to the Navy? Oh my god. Well, that might prove a problem. I did not expect that. Like, are you doing engineering for them? Or just, like, being in the Navy? That's kind of crazy. I could, not do that. Oh, nuclear program. Okay, okay. So, yeah. Wow, that's a lot. I would not do that, actually. I would rather not be an engineer, but I had to work there. I think I'm gonna do some fluids, because I think I've exhausted the extent of the lectures, which they've covered the content that can get me to do those problems the way they want me to do them. I could do them, but... But me saying I wouldn't be an engineer for that stuff is also the tism. I'm very specific about morals and things. Can't wait till I can put the CS gas room in basic training. That's crazy. Nuclear power is, that's pretty cool though. That's... I don't know, I want to say it's scary, but like, it is just like using steam to turn a big fan, so, you know, it's not the scariest thing ever, I guess. Linear momentum conservation. I don't know which one should we do first. Solving for the force in the link and the tension or compression, so we gotta do both anyway. Be nicer. Be twice as nice, I don't know. Vex, that might be a little... like... why might be a little simpler. But actually, do I need to do conservation of linear momentum? That's a good question. Let's see. Well, so for our... Oh, this is very interesting. Okay, before I just jump into this, let me think about this. So, what we'll probably want to do is solve for FOY and FOX. Okay. Yeah, I did goof that a little bit. I don't want the weight over there. Because if I take the moment, it won't give me just the nice things. How would we even say that? 2800. 2800 will have nuclear heaters. Probably. Well, I mean, I don't know if you want that. I feel like that would be like a little scary to have in your, like, just next to you. If I take a moment at C, I can get the reaction stuff in O, but I'm not really too jazzed about the reaction stuff in O. I mean, I can then get the shear at C, but we don't really want that. We want the tension and compression as well. Nuclear fireworks consumer product for 4th of July. So true. Gotta pitch these ideas, man. That's gonna make you cash. I did not draw any R vectors. Okay, let's do that. Do I really need any? I guess I don't know, actually. I don't know where I'm gonna take a moment about, so I'll wait. Well, I do know. Actually, I lied. It's gonna be about my coordinate system. Why did I say I was gonna take a moment about here? That's not smart. Also, this is... I think I was doing this problem late at night. I don't want my coordinate system there. I want my coordinate system... Wait, no, I want... Oh, wait, no. We're chillin'. No, we're not. I lied. We're kind of chillin'. I could solve for a... No, there's no bending moment. I lied. Okay. I really just... If I move the weight here, then all my problems are gone. Is the weight there? Probably not. Like, realistically, like, let's be so real. This is probably a more realistic assumption to make. Which means, how do we get that out of there? I'd like it to go away, is the thing. Because I need to take a moment about O. I don't need to take a moment about C. I'm gonna need, oh, they give me that distance, that's nice. This one right here. I think I'm just gonna say it's over O for now, and we're gonna do the problem, and we're gonna see if I get the whole thing wrong. That means I'm moving my coordinate system too. not a super hard thing to do. Why? I just don't want to have to deal with that weight. They don't tell us anything about the weight. It's a bit of an insane assumption to make, but I'm gonna be doing moments. Well, okay, before I do this, let's think. Do I need to do a moment? Could I just sum forces with linear momentum conservation? Well, these problems are angular momentum conservation, so probably not, but, you know. Maybe just, let's see. I don't know FOY, I don't know FOX. If I took a moment out here, I could get FOY. And I wouldn't be able to get FOX. I took a moment about C. Which would be okay. I mean, I could solve for if the weight wasn't there. I don't know the weight. If I knew the weight, then I could solve for the tension compression force there. But raining flaming radiation from the sky is the best idea. I think Americans would be all over that. I think that's really what 4th of July is about, you know? Just a little healthy radiation. Get Fallout, get the development of Fallout sped up. I guess, no, I was gonna say, I guess if I move the weight to some random place, I could take what about the weight, and then I wouldn't have to deal with the weight, but I mean, that doesn't really help me at all for any reason. Yeah, let's just go for... Ow. Let's say it's on top of the other one. I think I gotta do that. Okay. It's above O. Doesn't really make any sense, but like, I mean, I don't know what else to do, you know? Do, angular momentum, I guess. Do I need linear momentum? Probably. No, I don't. Wait, but how do I get the X anyway? If I think about O, it's gonna obliterate me. It's gonna obliterate the X is what it's gonna do. But I guess if it just wants the force in the link... I mean, FOX is gonna equal FCX. Oh no, we're changing linear momentum, never mind. There'll definitely be some reaction force there. So maybe I do need a little linear momentum equation. Let's start with linear momentum, why not? There's no harm in it. Momentum. EQ. We'll do X first. Now we'll do Y first. Okay. So some of the body forces X, Y. Some of the surface forces Y. Equals d by dt. V rho dv plus, and we got two CS's, CS1 E, nope, okay, this is in the Y direction, so it's going to be V1 rho 1 big V1 dot dA1 plus CS2 little v2 rho 2 v2 dot dA2. Sick. Alright, this goes away. This does not go away. Surface forces in the Y. There are surface forces in the Y. That's our FOY, so... Oh, I think I flipped that, yeah. So these two summed up are going to be our... We might be able to cancel out, we might be able to dance around that weight at some point. By canceling it out. Ooh, actually... Yeah, maybe. Oh, likelihood that it's 1 is slim. Because it's not. But we'll go with it. we'll see. Okay, so CS1, V1, we know that V1 is V2. I assume they are, uniform V's over CS's. Incompressible as well, so we can pop all these out. I mean, it's fine. Minus, plus, basically everything pops out. So we got V, rho, or I guess rho V, rho V squared A. Yeah. So then FOY equals rho V squared A, which are all things we know. It's water, so that's chill. Now, I mean, I guess we can figure out... We could figure out the weight of the water. Probably. We know velocity and we know flow rate, so we could figure out an area. If we assume that there's uniform velocity over the surface, which probably... we're not given a diameter. Well, I mean, we can figure out the diameter, but we're not given like a weight of the pipe, which probably seems important. I mean, it's not negligible, I don't think. It's not like it's a very thin pipe. We'll leave it for now. Let's do it in the X and we'll see what we get. We might not even use it, but you know. FSX, heh. Amateur. CV, U. Also, I don't think that's a vector. That's a component of a vector. DS1, U1, rho 1, V1, dot DA1. Plus C. Oops, CS2. U2, rho 2. Cool. Alright, so body forces in the X, we have none, but we do have two reactions here, so that's the... Oh, wait. Oops. We have 3 in the Y. Whoopsies. Whoopsies. Don't worry about that. Okay, none here. That goes 0. So this is our F. Is it? FOX plus FCX equals. So this will be U. Wait a second. Wait, this is minus though. This will be 0. What? Oh, it's because I didn't put anything on it. That would be smart. Okay, the dot product here is not that. The dot product... Well, no, yeah, the dot product is that. But we want the x component of velocity for the other one, so it's not going to be 0. It's going to be like 1 minus... Okay, we want the... That's the y component, so that's going to be... Cosine 30? This is V2 cosine... How do I write that? Let's say... V1 cosine 30, like this. Write it sideways. V1 cos 30. So it won't be V squared. It will be V squared, but then cos 30. It's also not that. This is minus, this is plus. So it's 30 cos 30 minus 1. Well, I guess theta. Let's make it theta, not 30. Think. Yeah. And then we'll do the same for... Whoops. Yeah, because if we change the angle on that, it's obviously going to affect it, so... Gonna make it more or less force. And this is the same deal. So we've got U1, we can factor, so just like, I guess V, it's... Oh, wait. Oh my goodness, I am all over the place. This is 0. Jeez, okay. Yeah, that's that. There's no y component. Oh my god, I'm just going through the motions here. What the heck? Plus fy. I thought about it. I was like, oh geez. Okay. That is positive then. Okay, let's go through slowly. So the x component of this is v. V, so rho is going to be in both of them for sure. And v is going to be in both of them for sure. V squared, this dot this is the same, and this dot this, so this is going to be minus. It's going to be plus. Facing both the same ways there. And then, yeah, that's minus. And then we've got, so v squared a, and then we have a 1, nope, cosine, it's cosine, no, sine 30 minus 1, sine theta minus 1. Cool. Alright, so that's some stuff. I mean, it's not the worst. We can, you know, get rid of some stuff, probably. This force weight is still gonna be awful forever. So we've got some knowledge about the forces in the x. So we probably want to take a moment which gives us information about the x, which would not be taking it about O or C. I mean, there's some other place we have to take a moment about. Now, we could take it about anywhere where we put the weight, which might honestly be a smarter thing to do. But really, the only two places that make sense to put the weight, I feel like, are here or here. And moving the weight won't change our linear momentum, so that's fine. We can move it around still. If we do that, then we could also, you know, just take it from an arbitrary distance, I suppose. We could take it, we could say that we're taking a moment from, you know, if we said that it was here, we took a moment about the weight, we would get an FOY, we wouldn't get an FCY, we would get these two, which we could solve for. It would be essentially like 2 times, it would be like FCX times this. Or sorry, FCX plus that. If we have the FOY, we wouldn't be able to solve for. We don't have any applied torques because, well, it's not being applied. It definitely has to be with where it definitely has to do with where you put the weight. If you put the weight in the right place, then you won't have to deal with all this moment stuff. I guess if I put the weight if I put the weight directly on top of C, then I could solve for FOY. And that would give me but I want to get rid of both of the y's, which I don't know if I can do. Because the x's are collinear. But to solve for that FCY, I definitely need to... Let's see, so we have more information on FOY. Well, what did we end up with FOY equaling? Something with the weight, right? Yeah. Which is really unfortunate. Hmm. I mean, I could assume that the weight is not important, but that seems like an issue and a half. Maybe we try and solve for... See, the thing is, if I take a moment like about here, if I took a moment about here, I guess if I put the weight right here, I could solve for FOY. I could say FOY equals 0. Is that true? No. No, I could solve for FOY, and then I could get it in terms of like the area vectors that we're gonna draw. Means I have to move the coordinate system again. Oh, I think it should be here. I want to say it's like we might have to assume that it's right on top of C. That's kind of where I'm leaning. Like it acts right here. Then if we take a moment about there, then we don't have any FOX or FOX or FCX. We only have FOY and R cross Fs. Or R cross... Wait, do I? I think it would have a velocity. Angular momentum. Whoa. R cross... Yeah, sorry, R cross... Now, that's a defined height to V1 from the origin, and I guess there's a defined height from V2 to the origin as well, so that's not too bad. Yeah, I feel like this might be promising. But if we're able to solve for FOY, and I feel like C is a more logical place. The reason why I say not on F is because I feel like C is the more logical place to have that center of mass. But center of gravity. But if I took it about O and the weight was about O, we could just immediately get FCY. And that would be good for us. Which would sidestep that weight. And then we could take a moment about... more moments. One moment equation, pretty much. But I'd like to get the... I feel like I need the x's in there, unless we're saying the x's are not... the force in the link at C. I'm assuming it cares about that linear x change. I mean, there's a change in linear momentum in the x direction. You know what? Let me take a look at one other thing. So there's another problem that he gave us that I was talking with someone who was attempting it about. I was not doing this one, I was doing this problem too. He said it was the harder one. I don't really think it's that much harder. It's sort of the same issue that this person was running into, and I was like, oh, it's easy. It's not actually that easy. Here, this is the one. So maybe if we try this one, we mess around a little bit, we can see if we can figure out that weight. Because the placement of that weight is really what is going to make or break it. This one, it's a whistle. We have entering a pipe at a certain pressure, so there's a pressure force. I'm going to cut through the pipe. Enters at a rate of that under pressure, that, and leaves the whistle at atmospheric pressure, so I'm gonna cross here. It's not compressible, which is just sort of annoying, but We don't want to deal with the pressure force inside the whistle, so we're going to take the whole thing. Entering velocity is that, and the exhaust velocity is that, so we get two velocities. Calculate the shear and tension at A, along with the bending moment in the pipe at A. The net flow area. Oh, they gave us an area, that's nice. Okay, so we have our CV in this case. Huh? So we have an coordinate system. Doesn't really matter, but I'd rather do X and Y, I think. I mean, it is cylindrical. I just don't really want to deal with the with that. Oops. With that angle. It's just gonna be easier to do X and Y, I think. Still gonna do it symmetrically, but you know. We have a weight which definitely acts through the center. For sure. But I'm getting a little ahead of myself. We need area vectors. Oh, whoops. Also, this is sort of the CV. Me when I don't draw the CV. The DA2, B2, and then F. Nope, that's V1. And then DA1. I'm gonna move the V1 actually over here. We got space. Okay. So we did that, we're not gonna do R vectors yet. We're gonna do body forces we did. Surface forces due to pressure. Okay, there's a pressure force here. Gonna act through the center. No pressure force on the end because it's a free jet. Well, not because it's a free jet, but because they specify, because it is a air, so it's, you know, not necessarily incompressible. But we can say steady flow. And we can say uniform row across CS's. Okay, fluid pressure, fluid shear, and then reaction forces. So we do have some reaction forces here. We cut through stuff F, R, A, Y, and F, X. It's a little hard to see there. We'll do that. F, R, A, X, fracs. Put vector hats on them 1 sec. Bink, bink, bink. Okay. In this one, if we're trying to find the shear, let me see actually. When we did this one, I think we just took a linear momentum thing and because our flux was I think we would want to take it about the weight and just give the weight an arbitrary position, or yeah, the center of gravity like an arbitrary position. Then you can find FARX, and that's chill. But finding the FE is harder. Because, I mean, you could just give the weight an arbitrary offset, I suppose, and then just arbitrarily offset it, but that doesn't really make that much sense, because it probably definitely acts through the centroid. Yeah, we had our body force there, we had a bending moment about A. Yeah, so if we want to take a bending moment about A, we just take a moment about A. Chillin'. Really easy. These are some linear momentum fluxes. Forces causing linear momentum fluxes that are creating this bending moment here. A moment about A. But that tension and shear is very hectic. Wait, what if we just did linear momentum conservation? We would get the weight in there. Well, I mean, we could just use linear momentum conservation to solve for FRAX. That would be easy. So I guess, constant mass, then ln momentum EQ x gives us FRAX. So that's the shear. And then, I mean, ln momentum EQ would give us, EQY would give us F weight and FRAY together somehow. And then, I mean, you angular momentum gives us the TA or MA. But that force weight, huh? That's rough. It might be something about we have the flow, we have Q's. We don't have to worry about, we're given X and entering velocities. Also, yeah, 1200 feet per second is below 3000. Is it that much below 3000? Let's see. Oop, 0.4. Nope, so it's not incompressible. It is compressible. It's going fast. That's a fast whistle. It enters at a rate of 12 pounds mass per second, so that's a flow rate. I mean, we can say that the weight is the difference between the pressure and the reaction force there. Oh, wait. We know the pressure force. Yeah, we know the pressure force. Oh, we don't know the wait. We know the don't know the weight though. Wait. We know the pressure force is the thing. I bet there's something there. Pressure. I don't know. Let me take a look at ours again. So if we know that we don't have any pressure forces in ours, we have only reaction forces, which is just lovely. But see, the thing about this is our weight is more like malleable. We can move the weight around with some wiggle room. I mean, if we did move the weight and we said, okay, well, the weight acts up a little more and over a little bit more, then we could, when we take that, we could snag FCX. We would also be catching FOX in there, though. But we do have a relationship between FCX and FOX, right? This one. But it's related to the weight anyway, so, like, what the hell? It might even just give us the same equation. Oh, it would probably give us a slightly different equation. Right, because the R's cross the... Weird. Well, maybe I'll just leave it for now. I do have to go do something. 3. Well, not at 3. I have to go at 3. I think we'll probably open next time by solving this one, finishing it up. I don't know when. Not exactly sure. But we'll get to it. Or I'll, like, mention how I solved it. Probably closer to the latter. Maybe... Wait a second. Before I go, let's check the textbook real quick. Always a good idea. Always a good idea to check our textbook. They might do something exactly like this, and then I'm just like, well, I thought about that for half an hour. I mean, it's still good to think about it. That's lift. I do not need that. Also, oh my gosh, we got to see Bernoulli's equation in class today, and I was like, oh, that's my boy. I know that guy. Now all we need is Torricelli, who I'm fairly certain we're not going to talk about. He's not really that interesting, unfortunately, and you can kind of just prove his thing. Oh wait, basic equations in integral form, angular momentum principle, equation for fixed control volume, a lawn sprinkler, Calculate the jet speed relative to each sprinkler nozzle. Evaluate friction torque. Yeah, they don't really have a weight there, do they? I guess they're not really. They know that it's gonna be the same, like, it's gonna be balanced with the reaction. Is there any way where we can eliminate the weight? A control volume full of nothing. No, I'm kidding. Not gonna be that. Well, okay, cool. They did nothing there. That's great. What about momentum? Maybe there's something with momentum here. No, because it's really... There's a person on top of that rocket that they drew. Let's see. Did they draw the weight here? They did not draw anything. I love that. Wait, they didn't draw the body force? Why did they not draw the body force? What? I mean, okay. Oh, I guess they calculated it, but like... So they just called theirs like G mass of the control volume. Where did that go? Theirs is leaving. They have a DDT, I think. Yeah. Oh, they have a moving. This is for moving CV. That's not what we're doing. This is also moving CV. I don't know. I'll have to ask about the weight. This one looks maybe like... No, that's not moving CV. Like easy though. It's like easy peasy. Wait, did they give it a mass in this one? No, interesting. Oh wait. Yeah, they're not. So what did they do with their mass? Wait. Plus mg. Oh my gosh, neglecting the weight of the vane. They just neglect the weight? Are you kidding me? They just neglect the weight in this one. What? I mean, I guess I could just neglect the weight. I guess I could just solve for it using mg and then say neglect the weight. How could you neglect the weight? That's kind of silly. Maybe you just have to neglect... But like, it feels like it's not neglect. I mean, how much water? It's probably a lot of water. 24 meters per second. Flow rate is 0.2 meters cubed per second. Cubic meters? 0.2 cubic meters. How big is a cubic meter? Let's see. How much does it weigh? Oh my god, 1 cubic meter is 2205 pounds, so... like 400 pounds of water. Okay, the weight might be neglectable. If it's an open pipe, let's say that it has a fairly thin diameter. Let's say it's made out of like... What would this be made out of? This might be made out of like... something that doesn't like... wear. I mean... It's welded, so it's probably metal. I mean, I guess it could be like copper or anything. I could figure out the area of it. Let's see. So the area would be Q equals V over A, so 24, Q equals V times A. So 0.2 divided by 24 is our area. Cross-sectional area is 0.833 meters. Made out of metal, 0.8. 0.00833. Times some. Oh, well, this is in millimeters. The pipe is Okay, you can probably neglect the weight. If it, I realize it's in millimeters. If there's that much water going through it, but I mean the water weighs stuff, right? I'll solve it with MG, but I feel like we could maybe neglect the weight of the pipe itself. Maybe not the weight of the water, but you could actually find the weight of the water at any given point. It would be a little annoying, but... Alright, I gotta go study for a class that's not teaching me anything, so gotta go teach that to myself with something else. But I will be back at some point. I'm gonna try to be back on Friday, but I have a thing I'm doing on Friday, so I might not be able to. But then it would be Sunday. A little far. Sorry, everybody. But we'll be back. Yeah, I'll see you then. Sorry for the little short stream, but I'll upload stuff. So if I miss streams, then I've been uploading. Every time I haven't been streaming, I've been uploading to YouTube. That's sort of how I've been. So, everybody has a great day. I'll see you later. Bye.